So in this presentation, I'm going to tell you about energy and how energy is related to the changes in the different states of matter. And by that, what I mean is how energy is related to changes that involve a solid becoming a liquid becoming a gas. So just to review, remember that matter it's anything that takes up space, which means that has a volume and has a mass. So everything that occupies space and has a mass is classified as matter. We can classify matter or subclassify matter depending on the composition. That's one way. And composition, what I mean is that we can classify matter as pure substances, depending if the substance that you're looking at it's a compound or an element, or we can classify matter as mixtures, and we have two different types of mixtures: homogeneous mixtures and heterogeneous mixtures. Matter can also be classified depending on the physical state. So we can classify matter as solids, liquids, or gases. So we have different properties for matter, and matter can undergo changes. So matter cannot be created or destroyed, but it can be transformed. So we have physical and chemical changes. Chemical changes are those changes where what you have at the end has different chemical composition to what you had in the beginning. So the substances are actually being converted to new substances. Physical changes in the other part of my diagram here on the left. The physical change, what it's actually changing is just the physical state of the substance, not the composition. The actual composition is altered when you have a chemical change. For example, if you have water and water it's converted to hydrogen gas and oxygen, which are the elements that are forming your water molecule, that represents a chemical change because you start with water and then at the end you have elements. Okay, you have a compound in the beginning, and then when your chemical change is over, what you have is the elements hydrogen and oxygen. Since you're actually altering the composition of your initial substance, what you have right there, it's a chemical change. For a physical change, the composition is not changing. So an example of a physical change involving water is that if you have water as a liquid and your liquid is evaporated, then what you have is a physical change because you have water, your compound in the beginning, and then when you evaporate your water, you still have water, the compound. It's just that it's in a different physical state, but the composition of your water molecule is not changing. You still have your hydrogens and your oxygen in the water molecule. There are no chemical bonds that are being broken or formed in that change because it's a physical change. Now, change of state, what that means is that a substance that has one state is being converted to a different one. If you have a liquid, converted to a solid. If you have a liquid, converted to a gas. A solid converted to a liquid. All of those are changes of state. Whenever a change of state is happening, energy is involved. So energy is defined as the ability to do work. And in the same way that matter cannot be created or destroyed, energy cannot be created or destroyed. Energy can be converted from one specific type to a different one. So same as matter, energy can be transferred or transformed from one type to a different one. So matter can be transformed. You have a compound, it can be decomposed into the elements. You have two compounds, they can be combined to give you a new compound or elements. So they can be transformed. Some units of energy, just for you to be able to recognize a number as a measurement of energy. The unit for energy in the International System of Units is the joules. Okay? So abbreviation is just a J. We have also kilojoules and kilojoules. We have a conversion factor right there. 1 kilojoule is the same as 1,000 joules. Another unit is calories. Abbreviation for that one is CAL, and that C it's a lowercase c. And that's important because we have also another unit, calorie, where the abbreviation is just a capital letter C. So 1 calorie with the lowercase c is the same as 4.184 joules of energy. That's another conversion factor. Just some definitions here to go over different types of energy. Kinetic energy is the energy related to movement. A specific example for kinetic energy is thermal energy, which is heat. Now, heat and temperature are not the same thing. Temperature is a measurement of heat, how much heat you have, and the energy as heat. It's just that amount of energy that moves from something that is at high temperature to something that is at a lower temperature. Another type of energy is potential energy, which is energy related to a position. A specific example for potential energy is chemical energy, which is the energy that is stored in every chemical bond. When you have your molecule for water, H2O, you have your hydrogens bonded to the oxygen. Those chemical bonds, you see how I have highlighted in green, chemical energy, chemical bonds, in the actual lines connecting the hydrogens with the oxygen. They They are representing the chemical bonds. Those chemical bonds, they actually contain an amount of energy. To break those chemical bonds, you need amount of energy. When the bonds are forming, you're getting an amount of energy. So every single compound that you can get that involves chemical bonds will have this specific type of chemical energy associated to them. So when you have chemical changes, there's a chemical energy involved in those changes. So now let's look at how amount of energy or energy is related to the changes in state. When a liquid is converted to a solid. So we have these three different states of matter, right? Solid, liquids, and gases. I have a red arrow moving from the left towards the right side. That is representing changes from a solid to a liquid to a gas. Now the yellow arrow moving from the right side towards the left, gas to liquid to solid. That's the yellow one. Now the red one is representing amount of energy that is being absorbed. What that means is that for a solid to become a liquid, for a liquid to become a gas, energy is required. Energy will be absorbed, and those processes right there are endothermic. Endothermic means absorption of energy. So for a liquid to become a gas, energy is required. It will be absorbed. In the opposite direction, the yellow arrow, energy will be released. Those are representing exothermic physical changes. Okay? All of these are physical changes. It's a change of state. So when a gas becomes a liquid, when a liquid becomes a solid, amount of energy is being released. So let's look at specific examples here. And I'm just using water. Okay? But this we can find the numbers for any substance. So if you have 1 gram of water as a solid, for that 1 gram of water as a solid to be converted to 1 gram of water as a liquid, you see my number 334 joules. For that 1 gram of water as ice, because it's a solid, right? To melt, to give you 1 gram of water as a liquid, 334 joules of energy are required. They have to be absorbed. Your 1 gram of water as a solid will absorb 334 joules of energy to become a liquid. Now, on the bottom part, you have in yellow negative 334 joules. What that means is that if you have 1 gram of water as a liquid, and now you're freezing that liquid to get a solid, 1 gram of water as a solid, 334 joules of energy are going to be released. That negative number is not a negative amount. That negative number represents that the amount of energy is being released. The positive number represents that that amount of energy is being absorbed. Now that number for water, for your 1 gram of water becoming 1 gram of water liquid, solid to liquid, that represents the heat of fusion, which is the specific amount of energy that you need to melt 1 gram of a substance. So that number is specific for 1 gram. If you have a different amount, we can actually calculate how much heat will be required for that specific amount based on this number. In a similar way to what we have for a solid to liquid, we have for a liquid to gas. So we have defined as the heat of vaporization, that amount of energy that is required for 1 gram of water, like I'm looking at the numbers for water, or for 1 gram of a substance to actually go from a liquid state to a gas state. So my numbers here at the bottom of the page, they are for water. So when you have 1 gram of water as a liquid and you want that 1 gram of water as a liquid to become a gas, 2,260 joules of energy are required. Your water as a liquid needs to absorb that amount of energy in order to become 1 gram of water as a gas. Okay? So that number represents the heat of vaporization for water. But in a similar way as we have for the heat of fusion, you can find those numbers for other substances. So when 1 gram of water as a gas are going back to a liquid, 2,260 joules of energy are going to be released. So positive number for the amount that it's being absorbed, negative number for the amount that it's being released. So here I have an example of how we can use this heat of fusion and heat of vaporization to calculate amount of energy that it's required for different amounts, okay? Not just 1 gram. So by definition, I have 1 gram of water. It's equivalent to your 334 joules. And that's the heat of fusion. Remember, this is for your solid to become a liquid. So let me write it down. So for 1 gram of water as a solid to become a liquid, 1 gram of water as a liquid, 334 joules of energy are required. So this is my heat of fusion. Now, in the problem, this is asking you how much energy or the amount of energy that it's going to be required for 100 grams of water to melt. So my number here, 334 joules, it's for just 1 gram of water. Now in your problem, what you have is 100 grams of water. So this is a problem where we use that heat of fusion as a conversion factor. If for every gram of water you need 334 joules of energy for that 1 gram of water to melt, when you have 100 grams of water, this is how we use that number as a conversion factor. If you have 1 gram, you need 334 joules of energy. Now you don't have 1 gram, you have 100 grams of water. When you multiply your 100 grams of water by your 334 joules of energy, that's going to tell you the amount of energy that it's required for you to melt 100 grams of water. So just to review, whenever we have an equality like this one, right? Like your heat of fusion, we can always represent something like this, that you have two numbers equal to each other and they have different units. We can always represent any equality as two possible conversion factors. 1 gram on top over 334 joules. 334 joules over 1 gram. Always two possible ones. The one that we're choosing, it's always the one that has the unit that we're trying to cancel out on the bottom, the unit that we're trying to get on the top part. Since this problem is trying to calculate amount of energy, you need unit for amount of energy on the top part. So I'm using my heat of fusion as a conversion factor to actually calculate the total amount of energy that it's required. If you don't have 1 gram, you have 100 grams. So your number 334 represents the amount for 1 gram, and what you're calculating represents the amount of energy required for 100 grams of water to melt, or to go from a solid to a liquid, right? That's melting. So if you do in your calculator 100 times 334 divided by 1, that will give you 33,400 joules of energy. Grams is canceling out and you're getting a number in joules, which is amount of energy, which is what you're trying to calculate.